Level 1. The Einstein-Rosen Bridge. The story of the wormhole begins not in imagination, but in mathematics. It was 1935, and Albert Einstein, already weary from years of wrestling with gravity's mysteries, sat alongside his colleague Nathan Rosen, searching for something that shouldn't exist away around infinity. Einstein's own equations suggested that space and time were not rigid and absolute, but a fabric elastic, continuous, and responsive. Under enough mass, that fabric curved, and under too much it tore. The singularity of a black hole represented a breakdown, a point where the math refused to cooperate. But what if that failure was really a doorway? As Einstein and Rosen worked a strange picture emerged, their equations described two regions of spacetime connected by a narrow throat. They had unknowingly sketched the blueprint for the first wormhole, a tunnel linking distant points through geometry itself. To visualize it, imagine a sheet of paper as space. Draw two dots far apart, two galaxies perhaps, and fold the paper so the dots touch. A line drawn through the fold becomes a shortcut. That, in essence, was the Einstein-Rosen Bridge. It was elegance born from equations. Yet nature, ever the pragmatist, added cruelty. The bridge collapsed instantly. The gravitational forces that opened the throat crushed it. It shut faster than light could cross. If you attempted the passage, you'd never even see the other side. Space-time would snap closed around you, like a fist tightening. Still, that fleeting geometry changed everything. The bridge revealed that space was capable of extraordinary shapes. Reality, it turned out, could bend into forms that seemed to mock distance itself. Einstein wasn't dreaming of interstellar travel. He was solving a problem, but the bridge he found became a beacon, a whisper from the equations themselves. Distance may not be what you think. The seed had been planted. The thought that space might connect to itself, that there could be hidden corridors between stars, was now immortal. Level 2. The Schwarzschild Wormhole. The next chapter begins nearly 2 decades earlier in the trenches of World War I. Amid gunfire and mud, a German physicist named Karl Schwarzschild solved Einstein's newborn theory of general relativity from the front lines. His exact solution described the gravitational field of a perfectly spherical mass, and it contained a secret. Hidden in the mathematics was a tunnel. The Schwarzschild solution possessed two asymptotic regions, two universes in effect connected through a narrow bridge. A traveler could on paper fall into a black hole in one universe and emerge from another. The notion was audacious, but the moment you tried to cross, the dream died. Inside the event horizon, the point of no return, the wormhole's throat collapses. Every particle, every photon, is dragged toward the singularity shredded by tidal gravity. Time itself tilts forward, forcing all paths inward. Imagine watching from outside as someone falls. You'd see them slow, redshift, and fade frozen on the horizon. To them, the fall is swift, unstoppable. There's no sideways movement through the bridge. No other world awaiting, just descent deeper and deeper until every clock stops ticking. And yet mathematically, the doorway remains carved into spacetime's equations. It's there, written into the architecture of reality itself, a possibility the universe seems to dangle just out of reach. The Schwarzschild wormhole is less a passage than a taunt. It tells us nature can make bridges, but never ones we can cross. Still, that impossibility inspired generations of physicists and storytellers to ask, what if the equations could be persuaded to stay open? Level 3. The traversable wormhole. In the late 1980s, that question found its champion. Physicist Kip Thorne, guided by both science and imagination, set out to determine whether the universe truly forbade stable wormholes or whether it merely demanded something we hadn't yet discovered. His team's calculations were revolutionary. They showed that the equations of relativity could, in theory, permit a wormhole that stayed open if it were threaded with a form of exotic matter, a substance possessing negative energy density. Normal matter bends space inward, Exotic matter would do the opposite, pushing outward, counteracting gravity's urge to collapse the tunnel. This hypothetical material doesn't exist in any known quantity, but glimpses of negative energy appear in quantum phenomena, like the Casimir effect, where virtual particles flicker between plates in a vacuum, briefly generating repulsive forces. If such effects could be amplified, a traversable wormhole might become reality. You wouldn't need faster-than-light engines or warp drives. You'd simply step across the folded page of the cosmos. Picture it a ring shimmering like dark glass, suspended in nothing. Step forward, and the universe dissolves around you. One heartbeat later, you emerge beneath the light of another star. No acceleration, no years lost. The entire galaxy becomes a walkable map. But the cost would be incomprehensible. The amount of negative energy required could rival the total output of suns. Without perfect control, the structure would implode, annihilating itself and everything nearby. Thorne's work didn't just stretch physics, it inspired it. Science fiction had long dreamed of wormholes. Now, physics gave those dreams equations. The door might still be locked, but at least humanity finally saw the keyhole. Level 4. The Time Machine Wormhole. Once the door exists, another question follows naturally. What happens if the two ends move through time differently? Because space and time are woven into one fabric. Bending one inevitably twists the other. If you take one mouth of a wormhole on a high-speed journey, accelerating it near light speed or parking it near a black hole, relativity dictates that its internal clock will tick slower. When you bring it back, one mouth will be younger than the other. Now, connect them again. Step through the older mouth, and you emerge from the younger one into the past. For you, the journey feels instant. For the universe, causality just broke. Could you send a message back? Could you meet yourself? Could you alter history? The equations say yes. Logic screams no. Stephen Hawking proposed that the cosmos itself would intervene. The chronology protection conjecture, quantum fluctuations, would flood the wormhole, tearing it apart before paradoxes could manifest. Reality, he argued, polices itself. Others disagree. The many worlds interpretation offers an escape clause. Every paradox births a new universe. Kill your past self, and you don't erase your timeline, you branch it. The original continues untouched. In that view, wormholes aren't time loops. They're splits in the tree of reality. Each use creates a new limb, another version of existence unfurling into being. If that's true, wormholes could be the ultimate editing tools of the cosmos, not corridors through time, but the machinery of possibility itself. Imagine standing at the mouth of one, staring into your own past. Lightning dances across the rim as space-time bends inward. Your reflection lags behind, delayed by relativistic distortion. You take a step forward and vanish into the before. Level 5. The Quantum Foam Wormhole. If you could shrink yourself to the smallest scale imaginable, to where the very concept of smooth space breaks apart, you would find chaos. Beneath the apparent stillness of the vacuum lies turbulence more violent than any storm. The quantum foam. At scales near the Planck length, 1 billion trillion times smaller than a grain of sand, space-time ripples with energy. Particles flicker in and out of existence, and with them, so does the geometry of reality. One instant, space-time bends outward, the next it knots upon itself. In this microscopic maelstrom, physicist John Wheeler envisioned countless fleeting tunnels, mini wormholes, each no larger than a proton, each existing for less than a heartbeat of creation. They appear and vanish faster than light could cross them. To us, the vacuum seems empty, but to the universe, it's frothing with gateways, each an embryo of connection. Wheeler speculated that if an intelligence could somehow trap one of these ephemeral tunnels and stabilize it, perhaps by injecting exotic energy at precisely the right moment, it could be inflated, stretched from subatomic scale to cosmic. The smallest quantum fluctuation could become a passage big enough to walk through. It's an idea, that redefines nothing. Space itself might be full of unformed bridges, waiting for a hand clever enough to hold one open. The raw ingredients for interstellar travel aren't scattered across galaxies. They're in the vacuum all around us. Every cubic centimeter of space could contain more wormholes than there are stars in the observable universe. They are there, dancing unseen as the universe rehearses creation on a microscopic stage. The only thing missing is control. Level 6. The White Hole Connection. Black holes are nature's ultimate trapdoors. Everything goes in, nothing comes out. But mathematics, with its merciless symmetry, demands a counterpart. The white hole, a region from which nothing can enter, only escape. If the black hole is the inhale, the white hole is the exhale. One devours, the other expels. Put them together, and you get a cosmic breathing machine, a wormhole. Some theorists propose that matter falling into a black hole here could emerge from a white hole elsewhere, ejected at near-light speed in a blinding jet. What we call destruction might simply be displacement. No telescope has ever confirmed a white hole, but the equations allow it, and the universe often builds before it explains. Some have speculated that gamma ray bursts, the brightest explosions ever observed, could be glimpses of white holes briefly flaring to life, spewing radiation from another reality. For a traveler, the journey would be lethal. You'd plunge past the event horizon, feel gravity stretch your body thinner than atoms, and then perhaps impossibly be reassembled in a violent surge of radiation on the far side. The exit would not be calm. It would be a storm of rebirth. Yet this theory solves a haunting puzzle. What happens to information inside a black hole? Quantum mechanics insists information cannot be destroyed. Relativity insists nothing escapes. The white hole connection offers a truce. Information is preserved, merely rerouted through a hidden door. If true, the universe recycles itself endlessly. Every act of falling in becomes a seed of emergence. Every death births another dawn. Level 7. The multiverse wormhole. Our universe may not be alone. Inflationary cosmology. Our best theory of the Big Bang suggests that space never stopped expanding. Pockets of energy cooled into universes like ours, while others kept inflating, creating an endless multiverse, a cosmic foam of universes, each with its own laws. Between these bubbles, energy fluctuations could rip small tunnels, multiversal wormholes bridging one cosmos to another. They might last milliseconds, or eons depending on conditions beyond our physics. Crossing one would mean leaving not just space, but the rulebook of reality. Gravity might be weaker, light might curve differently, even the chemistry of life could fail. Your very atoms might unravel because the constants holding them together no longer apply. And yet such bridges could explain mysteries in our own sky. Dark energy, that invisible force, accelerating cosmic expansion, might be the subtle tug of neighboring universes through unseen wormholes. Perhaps our universe is being pulled outward by its siblings. It's a mind-bending vision, an infinite ocean of realities connected by transient bridges, each universe a droplet in a cosmic rainstorm, colliding, merging, and splitting again. Somewhere out there, another version of you might be staring at another night sky wondering the same things. If wormholes truly connect universes, then every Big Bang could be an exit wound matter, spewing from one collapsing cosmos into another newborn, one creation, and collapse linked in an eternal heartbeat. The multiverse wormhole turns the universe into an ecosystem of realities, each feeding the next. The question isn't whether we're alone, but whether we ever were. Level 8, the holographic wormhole. In 2013, two physicists, Juan Maldacena and Leonard Susskind, proposed a unifying conjecture, ER equals EPR. It claimed that an Einstein-Rosen Bridge, ER, and Einstein-Podolsky-Rosen entanglement, EPR, are two manifestations of the same thing. In other words, entangled particles aren't merely mysteriously linked, they are physically connected by microscopic wormholes. This radical idea reframes the universe as a vast network of connections. Every time time two particles interact and remain entangled, a tiny bridge forms between them. These bridges are unimaginably small, invisible even to thought, but they stitch space-time together like the threads of a cosmic tapestry. Information that appears to teleport between particles isn't breaking physics, it's traveling through those hidden tunnels. Instantaneous connection becomes geometry rather than magic. Scale that up. Every atom in your body is entangled with countless others throughout the cosmos. If ER equals EPR is true, then you are connected literally physically to the stars. The entire universe might be one vast web of wormholes, every point linked to every other. In the holographic universe model, all of reality could be a projection from deeper informational layers. Wormholes might be the threads that encode that projection, the stitching between data and dimension. Think of it this way: consciousness could be the universe becoming aware of its own entanglement. When you feel awe, empathy, love, perhaps you're sensing the hidden connections that bind every particle, every mind. Wormholes then aren't just cosmic highways. They're the arteries of existence itself, the geometry of relationship, the architecture of awareness. Level 9, the energy trap. Even if humanity discovered exotic matter, even if we mastered negative energy and shaped it like clay, the universe would resist. A wormhole is an open wound in space-time, and nature abhors a wound. Every particle, every photon that enters, adds energy to the throat, curving it inward, tightening it, heating it. Radiation bounces from wall to wall, compounding until the entire passage blazes brighter than a supernova. The tunnel begins to sweat fire. To the traveler, it would be surreal. You'd stand before a circle of darkness, fringed in light, a shimmering halo suspended against the stars. The moment you stepped inside, the world would stretch. Colors would warp toward blue, then white. The air itself would hum like electricity. The walls around you would ripple like liquid glass. Space would vibrate. Each heartbeat would echo 1,000 times as gravity bent the rhythm of time. Then the tunnel would begin to contract, folding in on itself like a closing fist. If the collapse came too soon, you'd be erased in a fraction of a second, not burned, not torn, but unwritten. For you, there would be no pain. For the universe, a brief flash of imbalance instantly corrected. Physicists call this inevitability the energy trap. Unless negative energy perfectly counters the inflow of normal matter, collapse is guaranteed. To survive an advanced civilization would need godlike precision fields of opposite energy tuned to quantum accuracy dynamic feedback systems, correcting every fluctuation in real time. Imagine the technology required: machines the size of moons, humming at the edge of stability, a cosmic heart beating between life and oblivion. And yet we dream of it, because every great achievement of science has begun as defiance of nature's warnings. Fire burned, we learned to harness it. Gravity crushed, we learned to ride it. Perhaps one day, even space-time's temper can be tamed. The energy trap reminds us that the universe plays fair, but not gentle. It will allow miracles, but only to those who can withstand the price. Level 10, the cosmic network. If wormholes exist, perhaps they aren't rare at all. Perhaps they already lace the cosmos unseen, a hidden nervous system connecting galaxies like neurons in a cosmic brain. Astronomers mapping dark matter have discovered immense filaments stretching across billions of light years. These filaments form a web, a scaffolding on which galaxies cling like dewdrops. Some theorists whisper that these filaments could be ancient wormholes, remnants of the early universe, when space-time was hot and fluid enough to fold freely. If so, the universe isn't a collection of islands. It's a continent of connections. Every galaxy might hum to another's gravity through invisible bridges. The fabric that looks empty could in fact be woven with pathways older than stars. Imagine a civilization advanced enough to find one. Their probes would slip into the darkness between galaxies and vanish, reappearing where no light should reach for trillions of years. The cosmos would shrink from infinite to intimate. Distance would lose its meaning. This vision reshapes everything we think we know. If these tunnels permeate space, then travel, communication, even evolution might follow hidden lines of geometry. Perhaps black holes aren't the end of matter, but the switching stations of existence, transmitting energy through the universe's circuitry. But such a network would be delicate, each thread balanced on forces beyond comprehension. If one collapsed, the recoil could reverberate across creation. Entire clusters could shift gravitational tides, rewriting the architecture of reality. To look upon the universe this way is to feel both wonder and vertigo. We might not be floating in emptiness at all. We might be inside a living structure, the cosmos itself, breathing through its own veins. Level 11. The Quantum Blueprint. Every wormhole theory, every bridge, every equation is really an echo of the same desire to connect. Einstein's bridge, Thorne's tunnel, Wheeler's foam. Each is a translation of longing into mathematics. We search the stars not just for survival, but for symmetry, for proof that isolation is an illusion. Perhaps that's the hidden purpose of these equations, to remind us that connection is written into reality itself. In the quantum view, everything that exists influences everything else, however faintly. Particles on opposite ends of the cosmos share information instantaneously, entangled beyond distance. Maybe that's the true wormhole, not a corridor carved through space, but a relationship between all things. The more we study the universe, the more it resembles consciousness. Patterns repeat on every scale. Neurons and galaxies, synapses and star clusters, both transmit energy, both learn, both evolve. Maybe the cosmos isn't merely a stage for life. Maybe life is the cosmos studying itself. If so, the wormhole is not a machine we must build. It's a mirror we must recognize. The bridge already exists within atoms, within minds, within every interaction that joins one moment to another. And perhaps one day, when we finally step through a real wormhole, it won't feel alien at all. It will feel familiar, as though we've been crossing invisible bridges our entire lives. The dream of passage. Maybe the stars aren't far. Maybe distance is only the universe pretending to be vast, so that we'll learn the art of curiosity. We've chased wormholes for nearly a century, from chalkboards to computer models, from Einstein's quiet doubt to Thorne's daring hope. Each theory begins as numbers, then becomes something else. A story about yearning, about our refusal to accept boundaries. To imagine a wormhole is to believe that somewhere, somehow the impossible might already be happening, that there are paths the light of our eyes has not yet taken. Perhaps they flicker inside black holes stitched by gravity's invisible hands. Perhaps they flash between particles in the quantum sea, bridging moments of thought. Perhaps every act of love, every shared spark of understanding is the mind's way of performing the same miracle, folding distance into closeness. We may never build one, we may never find one, but the pursuit itself reveals something extraordinary. When we look for shortcuts across the universe, we are really searching for connection between places, between times, between each other. And maybe that's the final secret of the wormhole. Not escape, not conquest, but communion. The universe may be silent, but it is not indifferent. It waits for us to understand its shape, to realize that the bridge we seek is the very act of seeking. Maybe one day, under alien skies, humanity will step through and see another sun rising in another cosmos. Until then, we'll keep building, calculating, and dreaming, because the dream is the doorway.